And welcome everyone, and thank you for joining us today for our webinar titled Measuring Long-Term Wireless EEG in Rodents using Epitel-Epoch and BIOPAC Systems. This is Andy Henton from Inside Scientific, and it is my pleasure to be your host for today's event. Our session is sponsored by BIOPAC Systems and Epitel, and will focus on the fundamentals of recording wireless EEG in rodents, including transmitter implantation, equipment setup and operation, recording stable and accurate signals, and using essential data analysis features to simplify data review and calculations. First, we will be joined by Mark Lehmkuhle, Chief Executive and Technical Officer at Epitel Incorporated in Salt Lake City, Utah. Today, Dr. Lehmkuhle will review surgical procedure, device setup, and measurement best practices that will lead to successful and reproducible data collection using the Epoch wireless EEG and neural signal system. Following, we will be joined by Findlay, CEO of BIOPAC Systems Incorporated in Goleta, California. Today, Mr. Findlay will discuss multi-channel data acquisition, integrating video capture, tips for EEG data filtering and improving signal quality, completing EEG frequency analysis, and using software functions for seizure detection and sleep analysis.
Well, hello everyone. My name is Mark Lehmkuhle, and today I will be introducing you to the Epic Wireless Biopotential Recording System. And so we originally developed Epic out of the need to make long-term EEG recordings from rodent models of epileptogenesis of all ages, especially pups. Originally we were making our EEG recordings with tethered systems, which were just too noisy and restrictive on the animals, especially mice. And so we feel that we solve the problems with wired recording systems while offering an affordable wireless recording solution that we call Epic. The Epic system has since expanded to not only include EEG, but other biopotentials such as electrocardiogram, electromyogram, and multiple channels for animals of all ages. So the Epic system easily allows mixing two different types of biopotentials, such as EEG and EMG. So here's a short list of all the different types of transmitters that make up the Epic family. And new in 2017 is the reusable transmitter that is capable of mating with standard Plastics 1 style electrodes that are typically used for wired tethered recordings. Okay, so let's get started. This is an adult rat implanted with the Epic transmitter, capable of recording 2 channels of EEG for 6 months. So first we will demonstrate how to implant 2 different types of Epic transmitters for recording 2 channels of EEG in adult rats, postnatal day 21 rat pups, and P28 juvenile rats. And so many of the techniques shown here are also applicable to implanting mice, as well as the other types of signals such as ECG and EMG. And then after the surgery, we'll set up the Epic receiver and interface with the BIOPAC MP160 data acquisition system. Then I'll hand it off to Findlay, who will discuss how to set up the AcqKnowledge software, and then we'll analyze some data. So Epic allows you to record multiple channels of biopotentials from multiple animals simultaneously. So here we are recording 2 channels of EEG from 8 rats simultaneously. And in this case, what we're pointing at is an animal treated with the organophosphate DFP to induce status epilepticus. And what we're actually seeing in this channel are EMG artifacts induced by the peripheral nervous system effects of the organophosphate. So let's begin. First we need to activate the Epic transmitter, and all Epic transmitters are shipped turned off and ready to be activated when you need them. So the Epic transmitters are on these carrier boards for their protection, and you simply place the carrier in the activator over the Epic symbol. Press the power button, and then the activator will stay powered for about 2 minutes, and then pressing and holding the activate button will turn on the Epic transmitter. So the power LED on the left will illuminate after pressing the power button, and the check mark LED will illuminate once the transmitter has been activated. So after activation, place the activator with the transmitter on your Epic receiver and start your data acquisition system. And so with the data acquisition system running, you will see 2 separate sine waves. And you can use these sine waves to ensure your transmitter is functioning correctly and is operating at the correct gain setting prior to implanting your animals. And then you can also use this setup to test noise in your system when setting up your recordings. And Findlay will go over how to test noise in your system a little bit later. So with the activator and transmitter sitting on the receiver, the signal light should illuminate. If the signal light is on before putting a transmitter on the receiver, then you may have too much electrical interference in the room you're trying to make your recordings. Okay, the transmitter is now active and we're ready, so on with the surgery. So here's your typical surgical setup with the Dremel type burr tool there on the left. We've got a stereotaxic frame, there's some bone screws, the transmitters that we want to implant, our tray of sterile surgical tools, there's some sponges and suture, and some sterile gloves. So we totally recommend that you use a checklist for setting up your surgery so you don't forget anything. And if you don't have a checklist, we can provide one for you. So here we recommend 4 different types of forceps. There's some mixing dishes and a spatula. There's 4 hemostats, a needle driver, screwdriver, and scissors. So then from left to right, we have the superglue accelerant in a syringe. We have superglue, something that looks like eye lube, more superglue, a battery-powered electrocautery unit, which is essential, and some more eye lube. And from left to right, we have bone screws, the transmitters that we want to implant, soaking in 70% ethanol, and dental cement or polymethyl methacrylate. So now let's anesthetize our animal. And we recommend isoflurane inhaled anesthesia. It's really fast for induction and recovery, and is pretty easy to fine-tune. But injectable anesthesia, like a mixture of ketamine, xylazine, and acepromycin, will work, but it doesn't have that high throughput that we're looking for. But you really should use the anesthesia that your institutional animal care and use committee recommends. But in general, though, the quicker the surgery, the better the recovery. So then after the animal is anesthetized, place it on this water blanket and switch to a nose cone system on the left there, and it's called a rodent bane that delivers the anesthesia to the animal. And first we're going to apply some eye lubricant to the animal's eyes, and this will help protect them and keep them from drying out during the surgery. And then the final preparation step is to thoroughly shave the animal's scalp from ears to eyes. Okay, next we're going to put the animal in the stereotaxic frame. Oh, and notice now that we have switched to a postnatal day 21 rat pup. So throughout this video, we'll be switching around to different aged animals. And once in the ear bars, we want to swab the scalp with alternating scrubs of betadine and 70% ethanol. And then you'll want to cut the scalp in one continuous motion. So here's a pro tip. Use press and seal type cling wrap that you can get at the grocery store. It makes a fantastic surgical drape and even comes in holiday prints like zombies and Santas, maybe even zombie Santas. And then next, they're cutting the periosteum. And you want to clean up the blood from the surface of the skull. Make sure there's no dry blood in there at all, and it's clear of material. Then you'll take your 4 hemostats, and in the 4 corners of the incision, you'll gently clip the skin, taking a small bite. And using the weight of the hemostats, you'll hold the skin open while we work. One more hemostat. Okay, you'll need to stop any and all bleeding. And to help with that, you'll want to use an electrocautery unit in brief bursts to cauterize any bleeding bone. And you can see the unit glow red hot, so don't hold it there for very long. We just want it there just enough to stop the bleeding. So while you're stopping the bleeding, you'll also want to remove all of the periosteum from the skull. And this can be done by scraping it away, or here we're cutting it away. Or in pups and even mice, you might want to use a solution of 1% hydrogen peroxide to help remove the periosteum. And, oh yeah, we're drying the skull again. We got to make sure that's completely dry. That'll make or break how well the transmitter sticks to the skull. All right, now we're going to trim the electrodes to about 1 centimeter to check the fit. So this is the 2-channel 6-month transmitter, and we'll be drilling 3 holes for the electrodes. So note that if you're using the 6-channel transmitter, you'll be drilling 7 holes for the electrodes. Or if you're only interested in recording electrocardiogram or electromyogram, then you'll still be mounting the transmitter to the skull of the animal, but simply tunneling the electrodes ventrally through blunt dissection. So what we can see here is the surgeon is using the transmitter electrodes and the electrocautery unit to mark the skull where she wants to drill the holes for the electrodes. So just make sure you do not use the electrocautery unit on the electrodes themselves. So I'll stop here for a second, and I should mention that we have surgical manuals for all of these types of transmitters, whether you need EEG or ECG or implanting the Plastics 1 electrodes for use with a reusable transmitter. Okay, so now we are going to drill our burr holes using a Dremel type burr tool with a burr bit. And the animal you see here is P28, and so we'll want to put in a couple of bone screws to help anchor the transmitter. And so for adult animals, we recommend 3 screws, P28 2 screws, and younger animals, no screws. So we also have similar recommendations for mice. We find that stainless steel or titanium wood screws work great, and you can even practice on a block of wood first. Okay, we're back to our adult rat where we have 3 bone screws and 3 burr holes for the electrodes. And again, making sure that skull is dry. Next, we're going to recheck the fit of the electrodes. And so this is the 2-channel 2-month transmitter on a P21 rat pup. So right before the final implantation, you're going to cut the electrodes to length. And so it's very important to make sure the reference electrode is long enough to make good contact with the brain. Otherwise, you won't be able to record any good signals, and they will look extremely noisy. So typically, they're cut to be about 1 millimeter in length, and this will be one of the exceptions here. Okay, I'm going to pause just for a second. You'll need to be very careful with the electrodes. Because they are made of platinum iridium, they're very brittle. So bending them back and forth will cause them to break. So limit how much you bend those electrodes. So also notice here that the back of the transmitter rests on one of the bone screws. And so this is okay and may even help you save space on the skull, but make sure your electrodes are long enough in this case. So now we're ready to superglue the transmitter to the skull. You're going to put a bead of superglue along the base, making sure that it contacts the bone and the bone screws. So it's super critical that you don't get superglue on the electrodes themselves. So it'll act like an insulator, and you may not get good recordings. And once you got your superglue in place, you're going to dribble the accelerant on the bead of superglue, and this will cause the superglue to set up almost instantly. So be conservative with that accelerant. You also don't want to get that accelerant under the transmitter. And then immediately afterwards, you're going to flush away the accelerant with sterile saline. And then the final step for mounting the transmitter is to go back over the superglue with dental cement. And so the superglue leaves a bit of a rough edge around the edge there. And the dental cement will make a nice smooth transition, like a fillet. And you want to make sure there's no sharp edges around that transmitter. And you also want to make sure that you don't get any glue on the antenna on the top of the transmitter. So the EPIC transmitters need to be exposed for them to work correctly. Okay, before that dental cement sets up, you want to make sure that all the skin is loose around it. And so you can use the spatula as it's setting up to help smooth that edge of the dental cement and make sure the skin is loose. Okay, now we're ready to suture. Most suture materials will work fine, but we find that resorbable suture to be our favorite. And you'll want to start from the front of the transmitter and work your way to the back. And so now's a good time to mention that we have dummy transmitters of the 3 different sizes of the EPIC transmitter that we can provide you to practice these particular steps. And so they're made of the same medical epoxy as the transmitters themselves and are the exact same size. Now here's another pro tip. You can practice suturing on pork sausage, or so I hear. I don't know. I'm a vegetarian, so I don't know. Maybe you could practice on eggplant too. I guess just don't eat the suture. Although, I don't know, they're resorbable sutures, so maybe you could eat them. All right, we're just going to speed this up here. Okay, so in this case, the surgeon put 4 sutures in the front and 1 suture behind the transmitter. Okay, you want the skin to be fairly loose around the transmitter, and you especially don't want the skin to go over the transmitter. So if it's too tight, you may compromise the blood flow to the skin around the base of the transmitter. Okay, now she is dribbling Marcaine onto the edge of the skin, and Marcaine is a topical anesthetic. And voila, you've implanted the EPIC transmitter. So don't forget to give the animal some lactated ringer solution subcutaneously, as well as an antibiotic. Making a tent of the skin prevents you from injuring the animal. And once you have removed the anesthesia, you'll want to recover the animal in a clean cage sitting on top of a heated water blanket. Okay, and finally, when the animal is up and moving around, you can place it back in a clean cage and start recording immediately. So note that the signals may take 24 to 48 hours to settle down due to the surgery. So in this part of the webinar, we're going to set up the EPIC receiver. And we'll start with the power. Fairly straightforward. Next, we are going to take the BIOPAC cable 123, which has a bayonet BNC connector on one end and an RJ11 connector on the other. And we're going to plug that into channel 1. And we'll do the same for channel 2. Then there are two additional cables. The first is the auxiliary antenna cable, which has a stereo jack on one end and a small alligator clip on the other. And the second is a ground cable, which has a banana jack on one end and a larger alligator clip on the other end. Up next is the MP160. Let's turn it around and we'll first plug in the Ethernet connection. And then the power. So now we're ready to plug the EPIC receiver outputs into the analog inputs of the MP160 using the RJ11 connectors in channels 1 and 2. So I'm going to pause for a second. Note that there does not need to be an amplifier between the EPIC receiver and the data acquisition system. So the biosignals are already amplified on the output of the EPIC receiver, and all we need to do is digitize them. Okay, now all we need to do is plug the MP160 into any modern computer. You got your power and monitor connection, and we are looking for the Ethernet connection. So we'll simply plug it into the Ethernet port. I'll stop for a second, but what if you want to surf the web while making your wireless recordings? Not a problem. The MP160 comes with an Ethernet to USB adapter as well. So next we place the Faraday cage over the receiver. The Faraday cage is sized to fit the majority of the industry standard rodent cages. So I'm going to pause again and say that the EPIC receiver is also compatible with other chambers and custom cages and may not need to be used with the Faraday cage. And Fraser will talk next about how to determine noise levels in your recording environment. Now all we need to do is place the rodent cage on top of the receiver, and then you'll want to ground the Faraday cage to the receiver using the larger of the two alligator clips. And then the smaller of the two alligator clips should be attached to the wire top in the animal cage. And this will make the wire top serve as an auxiliary antenna, and is especially critical for recording from mice who like to hang from the wire top. And then we simply place the filter paper on top of the cage. So all you need to do is add mice or rats. The EPIC system uses capacitive coupling instead of standard radio frequency. And what this means is that the receivers can be placed side by side and even front to back. So this is an example of 12 mouse receivers on a standard rack in the animal facility that occupies only 2 feet by 4 feet of space. And so that includes a computer, the data acquisition system, and even a video feed for each animal. So such high throughput systems reduce the time to monitor a cohort of animals in a very compact area in your animal facility. You're well on your way to recording high-quality biosignals, whether it's EEG, electrocardiogram, electromyogram, or the like. And so lastly, I'll leave you with our example of recording 2 channels of status epilepticus in juvenile rats.
Okay, thanks very much, Andy, for the introduction. Welcome, everybody. And thank you, Mark, for that great presentation. So as Andy just said, I'm going to be talking about data acquisition and analysis this morning. And I'm going to recap a little bit on the part that Mark showed where he was interfacing with the BIOPAC MP160 system. I'll then walk through setting up the AcqKnowledge software to record the data. We'll look at multiple channel scenarios, up to 32 channels, even 48. We'll look at video capture, recording video as you're recording physiological data and making sure they're synchronized, and then looking at the playback options for reviewing the video and the physiological data. We'll then take a look at data quality and some things we can do to identify whether we've got noise in the data and how we can deal with those problems. Then we'll get into filtering for the different frequency bandwidths, alpha, beta, theta, delta, gamma. We'll perform a full frequency analysis. We'll then take a look at the seizure detection functionality within AcqKnowledge and regroup and take another look at how we can use the frequency analysis with the detected seizure areas. And then finally, we'll get into sleep analysis. Okay, so this builds on from Mark's presentation where he showed how to interface the MP160 with the receiver tray. And as Mark mentioned, the receiver trays have high-level outputs, so you do not require amplification. It's basically a BNC connector for the two signal outputs, and we connect to the HLT100C using the CBL123 cable. If you're using an MP150, you're going to connect to the UIM100C, the Universal Interface Module, via the CBL102 cable. So now we know how the hardware is set up. I'm going to switch over to the software and we'll take a look at how things set up there. So this file is a recording of 6 channels of EEG based on the configuration of the transmitters that are used. This could either be from 3 animals or 6 unique animals. But what I'm going to do is walk you through setup, and we'll circle back around and look at this data a little bit later on. So the first thing you're going to do is come into the file menu and select New. And the AcqKnowledge software will allow you to interface with multiple hardware devices. So if you've got multiple devices available, you select the device you're interested in, and I'm going to be using this MP150. When I select OK, the software wants to know what we're interfacing to, and I'm using the UIM100C because it's an MP150. So I'm going to select channel 1. Then we're asked the device that we're connecting, and the software contains the EPIC transmitters, and this is the dual channel EEG transmitter with a gain of 2000. By selecting this particular device, the software takes care of all the scaling for you. So you don't have to worry about that. So I'm just going to select a few channels. So this is analog channels 1 through 3. I can come in, I can add labels. I'll assume that we've got dual channel ones here. I can also adjust the sample rate. The default sample rate for AcqKnowledge is 2000, but for these recordings, we can get away with 500. We can also determine where we're going to save the data to. This is going to memory, but it could go to a hard drive. You can increase the length of the recording time, etc., etc. When I hit close, all I have to do is hit start, and now we see we've got 3 channels of data, and everything is scaled nicely based on those particular transmitters. Okay, if we want to do more than 16 channels, the MP150 is a 16-channel system, we can add another MP device. So this time I'm going to interface with an MP160. So this is all within the AcqKnowledge software. I'm going to add to the HLT this time because this is the MP160. The same list is available, so I'm going to select that same transmitter, and I'll add a couple of channels here. Again, I can enter a label, and I can adjust my sample rate. Okay, so now I can start recording from my MP160. So if we've got 16 channels on the MP160 and we've got 16 on the MP150, gives us the total of 32 channels there. I'm going to open this in its own separate window and move it across to the side and then adjust the MP150. So we're looking at both of these two devices. This is the MP150 on the left, which I can start, the MP160 on the right. They operate completely independently of one another, but you're all within the AcqKnowledge framework, and I can stop these independently. Or, using a nice tool in the software, there's an option here called Linked Acquisitions. This allows me to select the files that I want to link. So I've got Untitled 1, which is connected or associated with my MP150. I've got Untitled 2, which is associated with the MP160. Now, if I hit Start, both of these devices will start recording at the same time. I also have the option to merge all of the channels into one file, and this can be useful for analyzing at the end. Basically allows you to run through the analysis from one file rather than two separate ones. If you select this option, the software gives you some syncing options, and we're going to use the timestamp to sync. You also have highest or lowest sample rate, but we've got both of ours set the same, so this doesn't matter. If I hit Start, both of the devices started simultaneously. And if I come back into that dialog, I can stop the acquisition. I'm asked to enter a file name, and now the software has merged my 5 channels into one file. So the 3 channels labeled UIM with the device that was connected to it, 1, 2, and 3. Then the 2 channels down here labeled HLT are coming in from the MP160. So very easy to acquire data from more than 16 channels if your protocol demands that. Okay, so the next thing I'm going to look at is how we can acquire video at the same time as collect the physiological data. So from the top menu, we've got a media option. I can select setup, and I need to choose the video camera. I'm just using one USB camera here. I need to create a file name for it. And you can change the location from this browse option, so you can have the video saved to a different hard drive from the physiological data. When I hit OK, we now have our camera display, and we can see our rat with the implant mounted. When I hit Start, we're starting to record the physiological data and the video simultaneously. And that means that these two are now synchronized with one another. When I hit Stop, we've now saved the video and the physiological data. To give you a better idea of how this works in replay, this is the file I started with at the beginning. I can come back into Setup, and I can identify the file that I'm interested in. And open the playback viewer. So now on the right-hand side, I'm looking at the video that was acquired with this file. If I place the cursor anywhere in the physiological recording, it advances the video to the corresponding frame. Or I can replay the video, and on the left-hand side on the physiological data, you'll see the cursor moving through. So we can stop, pause, and this is the corresponding point where my cursor is that relates specifically to this frame in the video. So it's a very easy way of being able to identify periods of interest within the video and matching it up with the physiological data. So the next thing I want to do is look at signal quality. And I recommend connecting the EPIC tray, placing the animal in its cage, start recording data, but don't use the Faraday cage to start off with, and then come down to this tool menu here. This is the toolbar menu. We've got an option here for the spectrum analyzer. And this allows me to look to see whether we've got a lot of 60, 50 hertz noise. I'm just going to adjust the scale here. So we're looking between 0 and 120 hertz. So 60 hertz is right here, and there's absolutely no noise. Come back out to the 50 hertz region, just about here, we can see there's no noise. This can be done in real time. I'm doing it over this selected area here, and I can jump through the different channels. And I can see very quickly whether we're picking up any 50 or 60 hertz noise. And in this recording, there is none. If you do have 50 or 60 hertz noise evident, place the Faraday cage over the receiver tray, rerun the data again. Again, you can be doing this in real time. You don't have to do it post-acquisition. Look to see if that has cured your 50, 60 hertz noise. If it hasn't, and you're still seeing a little bit of noise in the signal, it's not the end of the world. If we go to the transform menu, to digital filters, there's a really excellent filter here, comb band stop. This is basically a filter that will run through and identify the line frequency. In my case, it's 60 hertz in the US, and it will look at any signals in that 60 hertz range, and it will remove any frequency components in that 60 hertz range and all the way up to Nyquist, all the harmonics up to Nyquist. So it's really eliminating all the electrical noise. Hit OK, and then we've just removed the 60 hertz, what little there was, from this section of data. So very easy to do that. I'm going to turn off some of these channels, so we're just focusing on the one. Next thing I want to look at is running a filter so that we can look at the different EEG bands. So from the analysis menu, we have electroencephalography, a sub-menu with a whole series of different options. The one I'm going to look at right now is deriving the EEG frequency bands. I'm just going to focus on this top channel. The software has run through and performed a bandpass filter, and it's filtered for alpha, beta, theta, delta, and gamma, and created new channels for each of these. So it's very easy to pull out the frequency information you're interested in, or the bands, I should say. The next I'm going to look at, this is the entire recording, this is over 2 hours of data. I can do a full frequency analysis. So if I come into the analysis menu, go back down to electroencephalography, and there's an option down here, EEG frequency analysis. I'm going to analyze this channel here, channel 3, select OK, and I'm going to use quite a wide epoch. I'm going to use 5 minutes, but this user selectable. You can use whatever time period you want. I'm going to analyze the entire graph, and then I'm going to output the results as a new channel and also into Excel. So the software is running through and identifying the 5-minute segments, and it's performing a full frequency analysis using the power spectral density tools within AcqKnowledge. Down below, it's creating unique channels for each of the measures that are being calculated, and then finally it will create a spreadsheet summary of those measurements. So Excel opens up. Each column has its heading, the epoch numbers, so 17 5-minute segments, the mean power, median frequency, mean frequency, spectral edge, and peak force. Down below, we've created new channels for each of those measures. So again, that can be done over user selected time periods. It can be much shorter or much longer dependent upon what you're looking for. Okay. Now I've got a file here. This contains some epileptic seizure data. And what I'm going to do is run through the automated seizure analysis. First off, I'm going to duplicate this waveform. So I've got two identical versions of it, and then going to go to the transform menu and run a difference calculation. I'm going to use 16 points. This is basically a rise over run analysis, so it's going to highlight the points where the spikes are really accelerating. And I'm going to use this to identify a threshold for my crossing level. From the analysis menu, I go back into the same EEG folder, and I'm going to use seizure analysis. I'm going to analyze channel 1, which is the red channel. I'm going to use a difference of 16 points, exactly the same as what I did for this channel down here. I can show the output of that, but I've already done it here, so I'm not worried. I'm going to create a threshold of 6,000. So any time across the signal crosses 6,000, I'm going to recognize that as a seizure spike. And I'm going to look at a window of 60 seconds. And any time I have more than 50 seizure spikes within a 60-second period, I'm going to classify that period as containing a seizure. I'm going to output the results to a new channel and to Excel. I run through, minimize this. We can see that we've got some spikes identified with these check marks on the red channel. This is our difference that we use to identify when the signals are crossing our threshold. This third channel, the green one, is a histogram of the 1-minute periods and the spike count for that 1-minute period. Okay. The fourth channel is showing the a range between 0 and 1, and where it goes high here, 1, this is indicating that we actually met our criteria of 50 spikes within that 60-second window. Down below, we have a summary of each of our 60-second epochs, where we get a count of the number of spikes that occurred within that 60-second period, and then whether we met our 50 spike classification. If there's a 1 in here, we know that we crossed our threshold. If we come down to the end, we can see the one where there were 50, which meant that we matched our 50 threshold, and a 1 appears in the third column. This is the summary of potential seizure epochs. There was only one found. So what I'm going to do, I'm going to rerun this analysis. Before I do that, I'm going to turn these two channels off. I run the analysis again using a different threshold. Run analysis. Analyze the same channel, channel 1. Everything's the same, only this time I'm going to lower my threshold quite significantly. And I'm going to output some focus areas and just send my results to Excel this time. I'm going to overwrite the existing marks. Okay, so now we can see we've identified many more spikes. If I come into my toolbar menu, I have an option here for focus areas. I'm going to turn the focus area on, and this highlights the periods that matched our criteria of 50 spikes within a 60-second period. If we come back into our spreadsheet, our summary is much larger this time. 1, 2, 3, 4, 5 areas. That matches up with the 5 focus areas. Our spike count is significantly higher, and we can see the ones where there is a match. We crossed our 50 or met our 50 spike count. And the nice thing about the focus areas, we can now use these to take further measurements or different analyses. What I'm going to do now is go back into the analysis menu. This time I'm going to run the frequency analysis on that same channel. only this time I'm going to run it for 60 seconds, and I'm going to just look at the focus areas, and I'll output my results to Excel. So before, when we ran this, we ran 5-minute epics across the entire recording. What we're doing now is just using those focus areas. So we're just analyzing the data that met our seizure criteria. And once this analysis is finished, we'll get a spreadsheet that contains a tab for each of the focus areas with the unique results for each of the 60-second epics. Okay, so this is the first epic. There was only one 60-second period there. We get the mean, power, median frequency, mean frequency, spectral edge, and peak frequency. This is for the second focus area, the third focus area, fourth focus area, and the fifth focus area. So basically those focus areas really allow us to perform additional analyses around the areas that we really care about. Okay, finally, you can also use the AcqKnowledge files to perform detailed sleep analysis. We use the sleep science software that will read in the AcqKnowledge files. The sleep science software will run through, will score the data and do a detailed sleep staging. So it will stage, score, and report the results. It's very efficient. You can do 24-hour recordings in approximately 5 minutes. The scoring is really very, very handy for anyone that's doing those detailed sleep analysis. And you basically take the AcqKnowledge file, open it up within SleepSign. The only thing you have to bear in mind, you do need to record EEG and EMG. So you need one of those transmitters that Mark talked about, which records 2 different signals, EEG and EMG. So we covered a lot of ground today, but don't be too alarmed because we do have unique video screencasts for each of the things that I presented in the webinar. So if you go on our website, look up the videos, you can find the unique screencasts for the things that you may be interested in. But we looked at interfacing the MP150, MP160 to the EPIC receiver, making sure that everything was set up and our scaling is correct. We can interface with third-party hardware. You do not need additional amplification. It's high-level signals coming from the receiver tray going to your hardware. We can provide cable recommendations for you dependent upon the third-party interface you have. We looked at setting up the software for recording. We looked at synchronizing the video during recording and then using the video for playback. We looked at data quality and elimination of 50-60 Hertz noise. Running filtering to identify the different frequency bands for alpha, beta, theta, delta, gamma. We did the frequency analysis, the seizure detection, and then we used the focus areas to run another frequency analysis over the seizure area. And then finally, we took a brief look at the sleep analysis software. So that concludes my presentation, and I'm going to hand over to Andy for our Q&A session.
We're going to start with actually a question that came in the registration form. So Mark, I think what I need you to do here is elaborate on the reusable transmitter that you mentioned in your presentation and what this will enable or what this will mean for users moving forward.
Sure. And my colleagues are telling me not to eat the sutures, which is too bad because I'm sure they taste like licorice. But so the reusable transmitter, this is new for us. And we found that a lot of people start off with tethered recordings and have experience with the Plastics 1 3-electrode system, which is shown here in the animal on the right being implanted. And what the reusable transmitter allows you to do is to interface with that electrode and move the transmitter from animal to animal to animal. And this is especially useful if you are only needing recordings for a very short period of time and have a lot of animals to record from. And it's also facilitates using a cannula system. So if you're going to, for example, inject canic acid into the hippocampus, it moves the transmitter away from the skull and has a very small footprint and allows you to have a cannula system there as well. And the other benefit is that you can turn this transmitter off when you're not using it, using the activator. So it still doesn't have a rechargeable battery, but by being able to turn it off, you can drastically increase the amount of time you can use this transmitter. So
Perfect.
I hope that answers the question.
Yeah, it does. And actually, just on that note, we've had a number of questions, again, before we started the webinar, the registration form, and even live today, about size and lifespan of the transmitters. So again, we've prepared an extra slide just to help get at these details. So Mark, if you could continue here and just help with the audience explain, so expected battery life of the transmitters, and then also how this varies by size. And actually, I'm going to elaborate one more on this. We have a question that has come in from Emma, and she's asked about the size and weight of the transmitters and how this might affect locomotor activity. And maybe you could focus on the 2-week transmitter on the pups.
Sure. Yeah.
Okay, perfect.
So we have 3 different size transmitters. They're on the right there, A through C. And starting at the top, we have our 6-month transmitter, which is the largest. But we only recommend that for adult rats. The footprint is fairly large. And then in B, we have what we call our 2-month transmitter. And that's great for adult rats and mice. It has a smaller footprint, and it'll even work in rat pups down to postnatal day 6, and then in weaned mice. So then in C, we have our smallest transmitter, and that's our 2-week transmitter. And that has a very small footprint, and if in the animal in the center there is a postnatal day 10 mouse, and it fits well on that mouse and is light enough that it doesn't restrict their movement. There is more information about these transmitters, such as the bandwidth and the weight and the volume, on our website at Epitel-Epoch.com, if you'd like to check that out. And I should mention that the reusable transmitter that we saw on the previous slide is the 2-month transmitter. And so regardless of the number of channels or the type of biopotential that you're recording, they all come in these 3 sizes: 2-week, 2-month, and 6-month. So
perfect. No, that's great. And actually, a question came in from Antonella that relates to this as well. They're particularly interested in maybe stretching the use of the smallest transmitter to P8 mice. Do you think that's possible, or has anybody attempted that?
I think it is possible. I'm not sure if anyone's attempted that yet or not.
Okay.
It doesn't mean that it's not possible.
Right. And that's what research is all about, right?
That's right.
Okay. Next question, Fraser. Do you have any recommendations for multi-channel video recording, either multiple recordings on a single subject or high throughput system with multiple animals being recorded simultaneously, much like the picture that Mark shared in his presentation?
Yeah, but we offer a number of different packages for multi-camera or single camera, high frame rate, high frequency type stuff. It really depends on what you're doing. If you're just looking at monitoring the animals while they're in their cages, the multi-camera systems work really well. We offer complete packages, and we have information on our website, and we can put details of those in with the Q&A section so that people can review them after the webinar.
Okay, perfect. Very good. Kind of on this, maybe related to this, Kirsten has asked, is it possible to achieve group housing in any way when using this equipment? So multiple mice, recording for multiple mice at the same time, but co-housing, I guess. Is this at all possible?
Yes, that is a fantastic question, and we are working on it, so stay tuned.
Okay, so coming soon. All right.
Yes.
Very good. Another question, Tao specifically asked, could you recommend the type of super glue that you used in the video, which is most appropriate for securing the transmitter to the skull?
Yes, there's a number of kinds that we've used in the past. Loctite makes a medical grade super glue that's approved for medical use, and I can make those recommendations offline as well. But there's a few different types.
Okay. Very good. Yeah, perhaps we can include some references to that. Also, the Plastics One parts that you mentioned, we'll include that in the report following the webinar, so people have some direct links. All right. Florbella has asked, do you absolutely need to have the receiver under the cage, or could it be oriented in different places within close proximity?
Yes, you do. Because it doesn't use radio frequency, it uses capacitive coupling.
Mm-hmm.
The animal has to have at least 1 foot over the area of that receiver. And so we recommend that you size the receiver based on the size of your animal. So if you're using a very small rodent pup, we have what we call the pup receiver. But we can also make custom shapes on a one-off basis if that's necessary for someone.
Okay. So more discussion required, maybe possible. Yeah. Okay. A question from Lynn. She's specifically interested if anyone is using this system for 26-hour continuous acquisition, but with integrated video. So I'll let you answer that first. Or maybe is that possible?
For long-term recordings?
26-hour continuous acquisition is specifically what she's mentioned.
Yes, absolutely. We have experiments going on here at the University of Utah, where we're recording continuously for 6 months from a cohort of animals.
Okay.
Continuously.
Excellent. So well beyond that.
Yes.
Very good. Fraser, can you mention the name of the sleep software? We've got a question coming. Just that someone would like for you to repeat the sleep software name so they can.
Yeah, Sleep Sign.
Okay. Very good.
And you can bring the AcqKnowledge file straight into it.
Okay. Perfect. What about an interesting question here? Maybe we'll make this our last one. Andrea's asked, could these systems be integrated with optogenetic equipment?
Yes, I think so. As long as it doesn't induce any electrical interference into the system, so like an optical system should work just fine.
Okay.
In my opinion. We haven't tried it, but I don't see any reason why it wouldn't work.
Mm-hmm. Okay. Fraser, any addition here? Have you heard of people doing this?
Well, I was just going to touch back on the 26-hour recording. One of the big things is file size.
Mm-hmm.
So AcqKnowledge is a 64-bit application, so it means you can record, huge files now. But one thing I didn't show, you can also automate the recording periods. So if you don't want to have one huge file of 26 hours of data, you can break it into chunks. And that allows you to access the data earlier in the process.
Okay.
So basically you could set it up, for example, to record in 6-hour chunks, and then at the end, if you really want to, you can merge it all back into one file, but sometimes it just makes it a little bit easier to handle if it's a smaller file.
Mm-hmm.
When you get to a large file, you have memory issues sometimes. So I don't know, it's just one of those things people have to play around with a little bit. But it is possible, and AcqKnowledge will support that through the 64-bit architecture.